Welcome back. In this video, we are going to talk about another one of the important concept of data structure, and that is stack is a linear data structure that follows last in first out principle. Stack can be defined as a container in which insertion and deletion can be done from one end, known as top of the stack. It is an important concept in programming. It is also important to understand when using recursion. Let's understand the concept of stack with the help of example. Imagine that you have a can of a tennis ball. The only way you can enter a tennis ball or remove it from the top. Stack works similarly in computer science. Stack can operate only two actions, push or pop. Both the job only can be done from the top. This type of data structure is known as stack. So computer uses a stack internally known as call stack. Now we will see how recursion uses stack. For that we are going to take an example. Here I am passing the first argument as 1. Now in this program what we are doing, we are just passing one value 1 as an argument and we are incrementing until and unless it is greater than 10, and after that we are returning 1. So how this program will call internally. When you call a function, the system sets aside space in memory for that function to do its necessary works. So we call that chunks of memory or stack frame. These frames are presented in the form of stack. Either you can push a function here or pop a function. In this example, first of all, if you will see, we are calling the main function. So main function will going to store here. The first function or object it is going to store is the main function, and after that main function what we are doing SOP, system.out.println. So this is not a function, but after that this objective should execute, right? So we are going to pass it here, and after that the next thing that we are going to do is we are going to call this method with an argument print one, correct? And after that, one by one we are calling the same function again. Here now I'm going to call print 2. Again we are calling again another one we are going to say it is going to call print 3. It is incrementing by 1 according to the logic in the else block we have written, and it is going to be done until and unless it will reach in a position where I position will be greater than 10. So like that the value is going to be stored here. Okay, now the top of the value will be the active state and rest will be inactive state. Okay, now what will happen? First of all, it is going to return when it will at the top of the position, and when it will reach, it will return when the i's value is greater than 10. This value is going to be popped out. Okay, after once returning of the i's of the value, again it is going to slowly means the second frame will become active and others will be inactive, and like that slowly it will popping out the values until and unless it will reach the position of print 1. When it will reach the position of the 1, again it is going to return here. After that, what is the next one is SOP. SOP will execute again. After the completion of SOP function job is done, he has printed the value, and after that what will be there? It is the end of the main function. That means main function also it will end. So it will all stack frames again, it will execute all the values and it will be completed. You need to understand one thing. So like that, it slowly by slowly it will stacks of frames will be executed according to the design of the program that we have written. Okay, and through that you can see that if the recursion will be much more lengthy or complicated, then a stack frame will be that much long, and if it will be long enough that the computer does not have enough memory, then we can see that one error will throw, and that error throw will be stack over error. When this stack frame is lengthy enough to, and it is spaces, all the space is taken by, and when it will happen, when you have given more than 10,000 or this program will, this recursion function will run as infinite loop. Okay, that we already talked in the previous video. So what we are going to do now, the program that we have written here, we are going to test in the Eclipse to see that it is properly, it is calling it or not. So let's do that. Alright, let's execute the code. So we are getting 11. Why we are getting 11? Because every time we are incrementing by 1, so greater than 10 is 11, and when it reaches to 11, it is start returning the values, and when the final loop of recursion will complete, it will print here 11. Correct? Okay, now one thing that we checked, okay, that's how this program will call function will done. Now another thing that is check what happens when stack frames will get loaded. For that, what we are going to do, we are just going to copy this one, Control X, and we are going to paste it here. Done, and let's run the program. So when this time what we have done, we have run the program as infinite times. So that means this will be very long. That means too many objects are created. So because of too many objects we have created, it lead to a stack overflow error. We can see that with the help of example only. If we remove the base case, then we can see that here stack overflow error is thrown. Okay, so with that we have covered this topic of call stack. So what are the things that we covered here in this video? We understood how, if we are writing any function, then how it will internally it will store the data and how it will execute, and if you are calling the recurring function, if you are calling the same function over and over, then how a stack frame will get generated one after another, and sometimes it will cause problems if it is long enough. With that, this is the end of the video, and again in the next video we are going to cover another one of the important concept of data structure. So stay tuned and keep watching Adhyan channel. Thank you.